Hello and welcome back to the PowerBuilder Fundamentals self-guided course. Today we're going to have a look at Unit 01, an introduction to the PowerBuilder environment. Unit 1's objectives are to describe the features and benefits of PowerBuilder, have a look at what an event is, identify common events for various PowerBuilder objects, explain how object-oriented programming differs from traditional, also known as structured programming, including the basic concepts of objects, properties, and methods. And we'll describe the features of a client-server development environment. So what is PowerBuilder? What is event-driven programming? What is object-oriented programming? And what is a client-server architecture? These are questions that we need to ask as we go through the topics in Unit 01. PowerBuilder applications provide the following: a graphical user interface to the business user, an event-driven processing model, and an object-oriented programming environment. Access to local databases and other network services or servers within a client-server environment. What is an effective graphic user interface? It's easy to create with PowerBuilder because PowerBuilder is WYSIWYG. What you see is what you get. To create an effective graphic interface, however, we need to use interface elements that are consistent within an application, and even better yet, across applications. From a procedural programming point of view or traditional programming point of view, this is what we used to do when we used to have programming languages like BASIC, COBOL. On the right-hand side, what we're looking at here is a flow between different screens. The user would enter the application at basically screen number 1 and have menu choices to go down either to the left-hand side, I'll call that workflow A, or the right-hand side, workflow B. The problem is when you're down in workflow A on the left-hand side, and you get to, let's say, a secondary screen 2 levels down, and then the user realizes that they needed some information from another part of the application, they may have to actually trip over here to the right-hand side, pick up some information, come back, and then continue on the business process. Unfortunately, in a procedural-driven environment, the application itself is basically like a tree, and you have to navigate the tree. So if you're down the left-hand side of the tree, you'd have to navigate back up one higher level menu, back to the main top level menu, down the right-hand side, down to the screen where you need that information. Unfortunately, you can't jump back to the left-hand side. You have to go back to the secondary menu, to the top level menu, and then back to the left-hand side, all the way back to where you were, now that you have the information you need to continue on and complete the business process on the left-hand side as an example. The problem with this traditional programming is all that navigation had to be in your code, and the application had to, and the programmer had to remember where they were within the processing sequence and allow the user to be able to navigate back and forth, but only through the hierarchy of menus. This is very cumbersome and not productive. So let's look at an event-driven programming model. Here in this case, we have all sorts of different objects, and they have particular behaviors, such as a piece of text, an edit box, a drop-down box, a list box, a command button, for example. And those behaviors are known behaviors, and you can place them all together, and these particular objects receive messages from the operating system. In PowerBuilder, when a message arrives at a particular object, that's called an event. An event can also execute some kind of known behavior or business process. For example, on the right-hand side here, we're assuming at the lower side a command button, and when the user interacts with it, some kind of behavior is executed, which you can also call a secondary behavior as well. Another command button, for example, could do something like, please open another window, where the user can enter some auxiliary information for that particular transaction, or look up some related information about that particular customer or part or whatever is going on. Those objects themselves also receive messages, and you can code for those messages arriving at a particular object, like a picture, for example. Or, for example, there could be many different types of messages. In the bottom right-hand side here, we're looking at possibly 3 different messages arriving at the window. These 3 different messages that you see down here on the right-hand side could correspond to the user interacting with the question mark here to get some help on a particular object that they're dealing with inside the window. It could be that they're minimizing or maximizing, they're closing the window, or they're grabbing the edge here to do some resizing. And these particular pieces of code that are attached represent different types of messages that are arriving at the window object, and then what kind of behavior you need to have when that particular message arrives and notifies you that the user is doing some particular action against the window. So what is an event? Basically, an action initiated by a user or the application. And we can also include the operating system in that realm as well. Basic examples would be clicking a command button, typing characters into a data entry control, selecting a menu item, moving to or from a control, moving the mouse around. So let's have a look at putting it all together and what we would do. That we know we can receive a message. In this example here on the bottom, you've been clicked, and the command button that receives that message now needs to execute some kind of behavior. Like, what do I do when the OK button is clicked? We call writing a piece of code for the OK button in PowerBuilder a script. So a script is just a small snippet of code that gets attached to an object and gets executed based on a specific event firing. So having a look here at this diagram, we can see here that we're actually inside the PowerBuilder IDE and we're looking at a command button called CB Update. We want this little code snippet to be executed when the user clicks the mouse on that command button. You notice that, for example, we could also write some code when something is dropped on the command button, or when the user arrives at a command button, which is get focus, or, for example, help here tells us that the user has grabbed the question mark at the top of the title bar of the window and dropped it on this command button and obviously needs some more information about how they deal with this particular object on the inside of your window. So let's look at some window common events. Windows receive events such as open, activate, mouse move, resize, or close. These are just messages arriving at the window notifying you what action is being applied to the window object itself. If it's a data entry, or what PowerBuilder calls a single line edit, here we have a user typing into an edit box the word Appian. When the user arrives at the object before they start typing, you receive a get focus. When they actually type some information in, you get a modified event. If, for example, they took the question mark and they dropped it on the edit box, you would get a drag drop event. And when they move away from this edit box to another object, you get a lose focus. So these are all events notifying you what's happening around that particular object. And it's up to you to write some code for it if you want. If you don't, PowerBuilder just generates a no operation. In other words, ignore. That don't do anything. With window events, you can also add to your event list any Microsoft Windows operating system event to your applications list of events. PowerBuilder automatically associates the common events, but you can map to any Microsoft Windows event or other events that may be related to other applications as well. We'll show you how to do that in the more advanced part of this fundamentals course in the later unit. You can create custom user events and write scripts for them. Custom user events are events that would only be fired between PowerBuilder objects. They're not related to your Microsoft operating system. They're something that means something to you from a business perspective. So let's have a look here and see how events are actually fired. So we've got a couple of demos here for me to run for you. First one I'm going to run is going to be based on the actual SPI utility that you can get from Microsoft called SPI++. I'm running on this particular machine under Windows 10, I'm running AMD processor. So I'm going to run the AMD version, 64-bit version of this particular application. And I'll just run this in admin mode. So this is the standard Microsoft SPI. And of course, here you can see File Manager at this point. So what I'm going to do, I'm going to actually ask the SPI utility to locate a window. And I can do that here by just dragging this icon onto the window itself. And you can see here that it's now identified a handle, which is really a pointer to that particular window. I'm going to ask it to watch the messages, and I'll hit OK here. And then we'll deal with that particular thing. For example, I'll just do something simple like just grabbing the edge of the file manager and just resizing it here. You'll see when I was doing that, I was getting all sorts of things, such as the window being activated, focus was changing within the window, background of the window was being erased and repainted. The window position was changed. In other words, the size was changed. The mouse was moving when I was resizing, and when it was moving, the left button was being held down on the mouse. So these are messages that are arriving to that window. You can see there's the window address here, 30 Baker 8 Easy. The message is Windows message underscore mouse move. And then there's some arguments that tells us exactly what was happening at that particular point in time. Some messages arrive that don't have any following information. Some messages arrive like this user message here, for example, that gives us a status code of what's going on. So the message is more specific. And we have to also interrogate the status code to refine exactly what kind of action was being applied to this particular window. So here's an example here of where the operating system via device driver, for example, a laser pen, a touch screen, a mouse, a keyboard, is sending those particular objects a message with some further information, and you need to deal with that. So let's close that, however, because this is a hard thing for the C programmer to undertake, is basically to handle all these low-level messages. So we want to move away from that. The other thing that comes with your course material, demo applications. So going back to where you installed Appian here, you created a folder called Appian Fundamentals, and you basically installed the demos that were available for your particular version of PowerBuilder. When you unzip that, it created a folder called Demos. Underneath that is another example application called Events. So let's run that now and see what happens. So here, this is a particular PowerBuilder application that's been written. Tracks what's happening here when you navigate through a drop-down menu. You can see here that within the center screen, you can see the event that's being fired, which is a select. And if I actually click on something, then we actually get a different type of message. For example, when we invoke the About screen, you can see here in reverse order, this is from newest at the top to oldest at the bottom, that we did select the Help menu at the top. We did navigate down to the Help About submenu, and then we actually clicked on the actual About menu. And of course, the About window came up. So these are events that are firing just on this particular object here called the menu itself, and child objects called menu items. So there are messages being sent to you at this point in time. PowerBuilder basically whittles those down into what it calls an event, which is a simplified version of all the messages that are arriving at those particular objects at that time. If we were to open up another window, for example, let's say here, window events without a database. What happens here, it opens up a screen that has objects here that are not interacting with a database, for example, a list box. But if we click into the list box, you can see here at the top left that we did get a get focus on the left list box, and we did get a selection changed when I selected the value yellow within the list box. If I have a drop-down list box and I selected the value Samantha, for example, we can see here again in the top right-hand side of this window that we did get a selection change in the drop-down list box, and we got a modified when I actually changed a selection within the drop-down list box. If I was to push the command button, you can see here the command button first gets a message or an event called get focus. The user's arrived here, and then a message which is an event called clicked, that the actual mouse has been clicked on that. Now the clicked event is very simplified. In order for that to happen, two messages arrived at that particular object, which is a left mouse down and a left mouse up. The combination of those two Microsoft messages got simplified in PowerBuilder called the clicked event. Same thing would happen, for example, if we went over here to a checkbox. You can see here, if I check the checkbox on the top right-hand side of that list, you can see the checkbox got a get focus and a click. If I go to the radio buttons and I click on that, the same thing happens. The radio button got a set focus, and then it actually got a button clicked on it, saying that the radio button changed states from off to on, because it's a synchronized pair basically at this point. If we went to a data entry box and I started typing in some characters, or I dropped something on it, then you would actually see some drag drop events as well into this edit box. Or for example, you went here and you selected something different here in the drop downs. You can see here that different events get triggered as well within the actual different object. If I open a window here that does have an interaction with a database, and you can see here that data has actually been retrieved from the database, you'll notice here on the right-hand side that if we scroll down a little bit, that we did get a retrieve start. So the retrieve start is telling us, hey, that SQL has been sent over to the database engine and some data is going to come back. Then we received retrieve row. That retrieve row is saying, hey, there's something coming back from the database. And that continued for the different rows that came back from the database server. And then we got an item focus changed and a row focus changed and an end retrieve, basically as the object here painted the data on the screen. So the retrieval has ended and focus has been placed typically on the first column within this particular data-aware object. So these are all events or messages arriving at your application, letting you know what's happening. You can either ignore them or you can react to them. Let's open up another one here called Sheet Events. And this one here is tracking all the other windows. Now if we go to the window pull-down menu and we cascade that, you can see here that there's different windows being run here at this point in time. Here's the one that's actually showing us what's going on to the windows in the background here. It's tracking Windows number 1 and Windows number 2. So when I come back here and I activate, for example, database window events with database connection, and then I go back to events with no database. If I go back here, you can see here that different windows, window number 2 did get a deactivate, window number 1 got an activate, which means I came back to it. And then I came back to this window here, which is showing us the overall window events. So window number 1 got a deactivate because I went back to this one that you see here. Same thing would happen, for example, if I drag the toolbars around. If I snap the toolbar to the other side, you would get a different message or event firing that the user has moved the toolbars. So various objects of various descriptions do get different events. Some are generic, some are tailored to the specific object itself and its behavior. So there's just an example of the event tracking application. You can run that yourself and you should see similar behavior demonstration that I just gave you. So in traditional structured programming, you have what we call a specific type and format of application based on the programming language. It's distinct to the programming code and its behavior. For example, we were showing earlier that you have basically a hierarchy of menus and you have to follow that hierarchy in a tree type processing structure. And everything therefore is processed sequentially in your code as well. But in object-oriented programming, which is what PowerBuilder is, it is a discipline in programming style, but it's available in many other types of application languages as well, and fairly common in today's developers' environments. It incorporates object-oriented features such as polymorphism, inheritance, and encapsulation, which we'll describe shortly. Programs consist of objects that interact with and make requests of each other. And we have to have a look at what is an object. First of all, an object is an entity, and it has a classification or a name. It has properties associated with it, and those properties can have values as well. The object may also come with methods that define a specific object's behaviors. We're going to have a look at how PowerBuilder further divides those into events and functions. But I just wanted to let you know that generically, if you're talking from one developer language to another, that if you use the word method, they'll understand what you mean. But PowerBuilder has a differentiation between a method called an event and a method called a function, which we'll have a look at shortly. So let's have a look at an example of objects in the real world and also in the PowerBuilder world. We'll have a look at the diamond structure here. So there could be different examples of properties here as a number of points on this particular diamond. The clarity of the diamond, the number of surfaces on the diamond, the weight of the diamond. We also have a house, and we have things such as a chimney. How many of those do I have? How big is it? We have a door. How many doors does the house have? On the outside, what is it made of? Aluminium or aluminum, if you want to call it that, brick, or some kind of wooden siding. What is the shape of the roof? Is it flat? Is it barn style? Is it an A-frame, like you see here? Or a folder, for example, does it have a tab on it or not? Does it open left or right? Is it a letter size or a legal size? It's the same thing in the software world. A window has the same thing. Does it have a control menu on the left-hand side? Does it have a close menu on the right-hand side? What kind of behavior does it have on the toolbar? Now, how big is the window? Same for a command button. How big is it? What color is it? What kind of text is on it? And we could have similar things such as a checkbox. What's the current state? It's not checked. Or a radio button. The current state is checked. So these are just examples of objects in the real world and objects in the software world that have basically properties and known behaviors. For example, a checkbox knows how to check and uncheck. A door knows how to open and close. A radio button knows how to basically activate and deactivate between radio buttons around it. Same thing with a window. It knows here that it has a control menu. And it knows how to activate that when you use the right-hand mouse button on the top. So let's look at objects within objects. You can see that in the real world we have a car here. Car has headlights, it has turn signals, it has a front radiator grille, it has wheels, a door, for example. Those are all objects within the larger object called a car. And those objects can break down. For example, the door on the left-hand side here of the car contains glass, it contains weather stripping, and it contains, for example, a side mirror. Those are also objects within the door itself, which is, of course, another object within the car. So the same thing happens in the software world. On the right-hand side, you can see a window. Inside of that are other objects, static text objects, edit boxes, also known as a single line edit in PowerBuilder, or command buttons. And each one of those has a behavior as well. For example, an edit box allows you to enter data. A command button, for example, knows how to depress and spring back when you use the mouse on it. Same thing with the turn signal on the car. Its behavior is when I have power applied to me, I know how to flash on and off. So what are properties? Properties are defining characteristics of an object, and they define the appearance of an object if it's a visual object. Properties don't change, but property values do change over time. So let's have a look at a comparison between a window and an edit box called a single line edit inside of PowerBuilder. You can see the first four properties are the same. Its current XY location on the display adapter and its width and height. However, some objects have specific properties. For example, the window here has a title, or the single line edit has a property called text case, which is either lower, mixed, or upper. So certain properties are very specific to the object, some are generic. Also, the value of the property then determines its size on the screen or its behavior. So having a look here at the objects that we just described earlier, if we change the width and height of those objects, then you get a scaling effect of the login window between smaller and larger. What are methods? Methods basically are behaviors of an object. And in PowerBuilder, as we mentioned before, there's two types of behaviors. Here's a behavior when a message arrives at an object, which is called an event. And here's a behavior that executes a unit of work or a known behavior, and that's called a function. So methods in PowerBuilder are broken down into two sub-definitions, events and functions. So PowerBuilder objects receive all sorts of different events. For example, you click the mouse, a constructor comes from the operating system saying, I've built the object in memory and it's ready to go. An open says that a window, for example, has actually been displayed in front of the user. The mouse could be a right button down. We should call it actually the alternate mouse button and the primary mouse button, and doesn't differentiate between a left and a right mouse user. However, PowerBuilder, like C++ or C# or Java, for example, always assumes that it's a right-handed person that's dealing with the application. So even though we call it right mouse button down, it actually may be the left button if the mouse is switched to left-handed mouse usage. Retrieve start is unique to PowerBuilder because it lets you know that SQL is being sent from the PowerBuilder application over to the database server for processing. So some of the events are specific to PowerBuilder, but most of the events correspond to standard Microsoft messages arriving at the application. Example of functions in PowerBuilder, denoted by the open and close bracket after the word. Open a window in front of the user, close the window that the user is looking at, show something that has been hidden, or something that is shown on the screen, hide it from the user's view with a hide. Or retrieve says basically send some kind of select SQL statement to the database management system to retrieve some data based on a criteria I'm going to pass you in the retrieve. Or I've got some changes that the user's made on the screen. I need to have those changes sent to the database to have those data elements updated. So here's an example here where we have a window that has a command button called close. The user can tab over to it and then hit the space bar on the keyboard or use the primary mouse button and he does receive an event. The event, of course, is the clicked event. The clicked event can be fired in either one of those two ways, by the keyboard or the mouse. It's just letting you know the user wants to basically process the logic behind the close button. In this example here, a script has been written, which is a small piece of PowerBuilder code that says, execute this command whenever this message arrives, which is the clicked event. And the command is, please close the window. Let's have a look at inheritance. The definition is a relationship between two or more objects where one object incorporates all or part of the definition of another object. In the real world, of course, we associate that to ancestor-descendant relationship, for example, between a grandparent and a child, where there's some kind of ancestor DNA that's passed down to the child. So we know that a specific type of hair color, a specific look of the facial features, or maybe a potential height that the child will grow to is defined by DNA code passed down from their ancestry. On the software side of things, we can do things exactly the same. We can say that we have object A, And we have object B, which is basically a descendant of object A. As a descendant, object B is basically picking up the properties and methods of object A. And we delineate that in an inheritance diagram by using two single tipped arrows instead of a full arrow. That is basically the signal for inheritance between two objects. So if you're making an object diagram, this is what you would use in your design of a parallel application. Encapsulation, another object-oriented property that bundles together properties and methods. Each object is treated as a package that contains the definition of the object and properties and methods. So it makes it really nice because the object becomes portable. It's basically a self-contained unit. It can be dropped in wherever it's required. We can also use an object-oriented property called encapsulation that allows you to hide properties of the object or even different methods or behaviors within the object as well, or simplify them. This process is also known as black box technology. For example, here when I hit the OK button, there's some kind of business process that gets executed. I don't know what it is, but I know that it always does something, and then it closes the window. The cancel button cancels whatever business process is running at that point in time and restores the particular window to its initial state. And the help button always understands where the user is processing within the window. And the object that they are actually focused on when the help button is pressed brings up the help subsystem with that particular information on that particular object, which is saying, hey, maybe you're entering a salary and within this particular company, a salary less than this amount and cannot exceed this amount for the type of job that you're basically describing at this point in time in the transaction. So benefits of encapsulation are increased developer productivity, shorter code development time because you code it once and then you can reuse it all over the place. Reduce code testing time because again, if you test it in its singularity, it works fine. If it worked based on the single object, it should work no matter where you place it. And also for code maintenance, the same thing. If it works in one spot on day one, and you go to change the code on day 15, for example, and you change that original unit of the object, and you test it, it should work exactly the same no matter where it gets placed throughout the rest of your application. It's not like in the old days where you had non-structured programming, and you would basically copy the same code all over the place, and then you had 15 places to maintain the code. Here you don't in Parallel if you use these kind of things such as encapsulation and inheritance. And of course, greater portability, not only to use the object in different aspects of your application, but you can also use it across different applications as well and code it only once. Polymorphism, the ability to hide different object implementations behind a common interface. So let's have a practical look of how that would actually work today. For example, we have a carton. It's some kind of a shipping container. There's an address on it, and somebody invokes it's time to actually ship this to the address on the label. So that executes some kind of business flow at that point in time. And the business rules get executed saying, hey, it has to be delivered locally, not too far away. The priority is as soon as possible. Then maybe the best way to ship it is through some kind of a local messenger. If the package has the same criteria, but the address is quite a distance away, but again, the priority is high, then the package may, from the business rules, choose an airplane to deliver that particular package. If the package is a little bit heavier and the shipping priority is medium, maybe we can choose a more economical route, which is, for example, the train. Or maybe a bus would be another good example. If the destination location is across some kind of body of water, then you may have to choose a ship, for example. Another consideration on a ship to address label would be there are some kind of dangerous contents of the shipping container. For example, something that like a mild vinegar, for example, that if it's spilled out of this container could combine with other material in other packages to form some kind of sulfuric acid, for example, hydrochloric acid. So in that particular case, based on the contents, we couldn't choose an airplane. We could choose a train or a bus. We'd have to go to some kind of a trucking with a special trailer to contain these kind of special materials that might be in this shipping container. So there's an example of polymorphism. However, it doesn't really matter whether we send the message to a pallet rack, to a shipping container, to an envelope, that the same business rules get executed and the decision of which route to go to get the package to its destination in the best and economical way is an example of polymorphism. Polymorphism in software, you can see here on the center here where we have window number 1, we have a PowerBuilder script that's sending a request to the window, says, can you please print the contents of the window on the printer. We also have another piece of PowerScript here which has a print command, but it's directed to the graph. And somehow the graph knows, for example, how to get itself replicated on the printer as well. So the nice thing with polymorphism in the software context is you can send the same command to different objects. They all respond, but they can all respond differently. But the end result is the same. We either get sent to the address on label or we get printed on the printer in this example. It makes the code easier to write. You know that objects around you will all respond to some kind of request, and you have one place to maintain the code. So greater flexibility, increased reuse of objects within the development environment, and even when you're building application number 2, 3, and 4, for example, because you can use the objects that you built in application number 1, and then you don't have to recode them. You just keep on reusing them, even across different applications. And you have a nice consistent interface for increased productivity. In other words, once you have an object that has a specific look and feel and executes a certain process, that it doesn't matter where you drop it in. It all works exactly the same. Let's have a look at the client-server environment, which would be true here for your basic two-tier client-server environment, where you have a group of PCs or you have a group of devices that are hooked to some kind of a communications network that communicate to various servers on the right-hand side. In the client-server environment, basically the clients from different applications and devices are making requests to the servers. The client-server environment, of course, consists of the client, the server, and the network. Its responsibility is to manage the user interface, execute the application logic, dispatch requests for services. That could be to the local operating system, other parts of its application, or to server components that are hooked to the network that it's corresponding with, and support communications with other applications. For example, your PowerBuilder application could have a direct communication to an Office spreadsheet or a word processor in the background as well, doing other work for you. And integrate desktop applications, for example, maybe bring in the Microsoft Calculator available within your application as well. And of course, it's going to check the data that's being edited to make sure that the data follows certain business rules, make context-sensitive help available, bring up a video tutorial for the user, or control navigation within your application as well. The server, of course, can provide all sorts of different services. We could have a file server, we could have a database server, we could have a server that basically checks integrity, validation rules, so there's some kind of business logic here that's being executed. We could have some kind of security, for example, Active Directory, where you can actually check the user's credentials, the application credentials, what the user can do with a particular application. Maintaining transaction throughput, performance, recovery if things go wrong. Maybe allowing distributed data, for example, through proxy tables. If you're a DBA, you'll probably understand that statement. And manage concurrency control, in other words, locking of files and records, while one business transaction is also processing similar information from another business transaction on another client. Or prevent other services like print and fax services or email, for example. The network, of course, provides the connectivity in the client-server network. It maintains communication between devices, and it may look something like this. It's important to note that PowerBuilder does not have any proprietary use of these interfaces to communicate from one machine or one point in the network to the other. It uses what it calls OSI, which stands for Open System Interconnection. Those are standard APIs that have been available for decades in the industry that allows common communication between these different. So first of all, it starts out with your desktop application. It wants to communicate to a database server, so it's going to use a standard API to call the database interface. This database interface has provided software from your database vendor. The database interface, for example, knows how to package the database request into a buffer that it passes to the network software, which packetizes it. The network software, of course, is standard API that knows how to basically packetize and then send it to your hardware, which is your network card, and then send that packet through the network to a specific location within the network. That piece of hardware will send back a receipt packet to the original one saying, hey, I got your packet okay. Once that acknowledgement has been confirmed, that I've actually got the actual information within that packet, or could be 2 or 3 packets. Then at the hardware level, it gives it back to the network software standard API, which allows us basically to reconstruct the request buffer from those packets. That request buffer is then sent to the database management system, which then interprets that particular request. Hey, can you get me some data about my employees where they live in the state of California, for example? So that access is being done. And now the database management system has a list of the California employees. That information is then basically constructed in a database buffer, calls the OSI API, stack layer to call the network interface to packetize it. Those packetizes are sent out to the hardware. As you can see here, the reverse happens now on the left-hand side. The packets are deconstructed back into the database buffer, and the buffer then returns you what we call an ANSI result set to the PowerBuilder desktop application, which basically now you see the data coming back from the database management system. Again, PowerBuilder doesn't use any proprietary software or special ways of doing that. It uses the standard Open System Interconnect API layer. So let's look at the advantages of the client-server environment. It's interoperability because of the standard OSI stack, which allows us to basically interoperate between not only different pieces, the client and the server, but even different operating systems, because the server can be something totally different than Windows. It can be Linux, for example. It could be Macintosh. You really don't care. It's scalable because you can change the pieces. You can improve the network bandwidth. You can improve the size of the server machine. You could put multiple servers on the system as well. For example, you can have 3 or 4 database servers and then create a distributed database network and not have all your data in one physical database. Adaptability is nice because, again, the OSI stack allows you to communicate to different devices using standard APIs. And, of course, cross-platform is supported because of that interoperability. And it's affordable, too, because you can start out small and you can add more pieces as your application and your user base grows. So in a multi-tier environment, client-server typically is what we call a 2-tier. You can have basically a 3 or 4-tier environment, or generically just call an N-tier. When we're referring to N-tier, typically it means that we've at least added an application server between the client and the database server. The application server basically contains the business logic and the business rules in a central location and is not based on the client itself. This allows us to actually execute business rules in a central location from different clients of different origins. For example, one client could be built on Java, one could be built on Delphi, another one could be built on C#, and of course another one on PowerBuilder, and they can all call these common business rules using standard APIs. This allows complete reuse of the business logic in all other applications, not only multiple PowerBuilder applications, but applications written by other developers using different languages. It offloads processing from both the client and or the database server, which is nice, another benefit. And it can reduce the number of data connections because data can be cached in the application server. PowerBuilder non-visual objects can be deployed to application servers on a middle tier. So we can make use of this particular aspect of PowerBuilder, this non-visual object. We're going to have a look at that in Unit 23 when we have a look at moving to N-tier environments. So in summary for Unit 1, we've had a look at PowerBuilder. It's a professional, powerful client-server application development tool for the graphic environment. The user controls the flow of processing in an event-driven programming model. An event is an action or message that's initiated by the user or the operating system or another part of your application to another part of the application, basically a message arriving in an object that needs some kind of action. Of course, an object can combine properties or characteristics and known behaviors, which we call generically methods, that do work for us. Properties, of course, control the look and feel of the object on the screen. Scripts are pieces of logic that you can attach to an object, and they get executed when a message arrives, or what PowerBuilder calls an event. Also, we looked at what is encapsulation. It prevents the user from seeing the internal workings of an object. In other words, making the object a black box and therefore portable, because you can drop it in wherever you need it, and you don't need to know the internal workings to know that it's going to do that specific look and feel for you and behavior. Polymorphism allows you to send messages to objects around you. They'll all respond, but they may respond differently, but appropriately. A client-server environment includes the client, the database server, and the network, of which you can see here the client controls the user interface, the application business logic, and how to manage requests for different things. The database server is responsible for serving up the data, handling things like security, and maybe distributing the workload across another database server. We're doing automatic backups. And the network, of course, is the connectivity and communication that you need. The N-tier environment includes the application server. And of course, we can also go even further. We can also have a 4-tier environment, which now puts a web server, for example, in between the client and the application server and the database server. So we have a Unit 1, Lab 1, that'll allow you to run a video that'll set up the lab number 1 by clicking the icon here in the center of the screen. This will expand our horizons on what we just talked about in the various topics that were covered in Unit 1.